first thing is what? The introduction to IoT. So IoT, it stands for Internet of Things. And what it does is it refers to the interconnectedness of physical devices. Physical devices are nothing but appliances and vehicles, digital machines, objects, animals, people. It can be anything. So all these physical devices, they're embedded with software and sensors. Okay. And then the connectivity, what it does is it enables these objects to connect and exchange the data between themselves. Okay. And this technology, what it does is it also allows for the collection and sharing of data, that too from a very vast network of devices. So this will create opportunities for more efficient and automated systems. Okay. And then one more thing is what? The ability to transfer the data over a network, which will require human-to-human interaction or human-to-computer interaction. Okay. And then comes the definition of IoT. So IoT is nothing but it stands for Internet of Things, and it is nothing but the networking of physical objects that contain electronics embedded within the architecture in order to communicate and sense interactions amongst each other or with respect to the external environment. Okay. And then advancements in medicine, power, gene therapies, agriculture, and smart homes, smart cities. All these are just a few of the categorical examples where this IoT is strongly established. Okay. Now let us see what is IIoT. IIoT stands for Industrial Internet of Things. Okay. It is nothing but the use of smart sensors, actuators, and other devices. Other devices include radio frequency identification tags. That's nothing but RFID tags. All these things are used to enhance the manufacturing and industrial processes. Okay. Below you can see the diagram of an RFID tag reader. Okay. And these devices, what they are done is they are networked together to provide or to help in data collection, exchange of data, and then data analysis. All these things can be done more efficiently and then with reliability. Okay. And this IIoT is also called as Industrial Internet. Okay. And this IIoT is used in many industries, which includes manufacturing, energy management, utilities, oil and gas, all these fields. Okay. And now let's look at the comparison or difference between IoT and IIoT. Okay. And then what this IoT does is it focuses mainly on the general applications, whereas IIoT will focus on industrial applications. And IoT, here we need not worry about life-threatening situations, whereas in IIoT, it will cause a life-threatening situation. Okay, because it uses some very critical and important equipments, and all these devices are interconnected over a network. So it will have a life-threatening situation. And then IoT deals with small-scale networks, whereas IIoT deals with large-scale networks. IoT can be easily used or can be offered for off-site programming. Okay, whereas IIoT, it can be programmed remotely and it offers on-site programming. That facility is also being offered. IoT, it handles very high amount of data or volume of data, whereas IIoT, it handles medium to high volume of data. Okay, and IoT, it requires identity and privacy, but IIoT, it requires what? Robust security. IoT needs only moderate requirements, whereas IIoT, it requires some strong or stringent requirements. And IoT, it has short product life cycle, and IIoT, it has long product life cycle. This IoT is less reliable, whereas IIoT is highly reliable. Okay. Then we have a look at the history of IIoT. This is nothing but it is called as a timeline of Industrial Internet of Things. Okay. First thing, in the year 1968, PLC was born. Okay. And in the year 1983, Ethernet was being standardized. In the year 1986, PLCs were linked to PCs. Okay. And in the year 1989, World Wide Web, it came into effect. In the year 1992, Ethernet and Transmission Control Protocol, or it is also called as Internet Protocol, okay, TCP or IP, that connectivity was being introduced. In the year 1994, the OPC Foundation forms were introduced for secured data exchange. Okay, and in the year 1995, MS Windows became the mainstream in the OS factory. Okay, and in the year 1996, OPC data access protocol was released. In the year 1997, wireless M2M technology, it became prevalent in the industrial area. And in the year 1999, Internet of Things was introduced. Okay, before that in the year 98, Internet turns 25. It means it was being used for 25 years. Okay, and in the year 1999, Internet of Things was being introduced. And then in the year 2002, cloud technology was introduced. Okay, with the launch of AWS. AWS stands for Amazon Web Services. And in the year 2006, this OPC, what it did was, it identified, that is, unified architecture protocol was being released, and this helped in secure communication between the devices, because network plays an important role in IoT. And then in the year 2010, sensors led to a very sharp drop in the price. And in the year 2011, BYOD, that is bring your own device, it became a mainstream. Okay, and then in the year 2016, this is where IIoT vision emerges. So what are the things that were important under this? First, what happened was the data scientists, they took charge. Okay, they moved into leadership, and then AR and VR, okay, they became standard UIs for user interface for the IIoT. And then the security, but the security, even then the security remained critical. The reason was IIoT was generally, it depended upon the network or the communication interface between the different devices, right? So it remained security, that problem, it remained critical. Okay, then we'll have a look at the different components of IIoT. Okay, then what? The Internet of Things. See, we know that IoT stands for Internet of Things. Okay, it is nothing but a complex system that is going to involve the interaction of various components among themselves, such that there's going to be seamless flow of data between them. Okay, continuous flow of data. Okay, and what are the fundamental we saw here? The fundamental components are sensors and devices. Okay, you can have sensors and actuators, then the connectivity issue, then the data processing, and then the UI or user interface. Okay, so what are the four fundamental components? First one is what? Sensors and actuators. Okay, in the block diagram, it will be given as sensors and devices. So sensors, what they're going to do? They are devices that are going to collect the data, or it is going to capture information from the physical world. And then it converts these physical signals into electrical signals. Okay, and these sensors, what they can do is they can measure various parameters such as temperature, humidity, light, motion, and so on. Okay, so this is the work of the sensors. They're going to what? They're going to convert the physical signals into electrical signals. Then comes the actuators. So these actuators are devices which can perform the actions based on the data which is being received from the sensors. What these actuators are going to do? They're going to convert the electrical signals into physical signals. Okay, for example, just consider linear actuator. Okay, what it's going to do? It is going to convert it into the electrical signal which is being detected or sensed. It's going to be converted into linear motion. What about rotary actuator? It's going to be converted into rotational motion. Okay, and you can say, for example, an actuator in a thermostat. Okay, what it can do is it can adjust the temperature based on the sensor readings. So what you can say. So this is about the sensors and actuators. Then comes the connectivity part. Okay, now these data which is being sensed and then converted, right? All these signals, it is being sent to the cloud. Okay, they can be connected to the cloud through a variety of methods. Okay, this will include cellular, satellite, Wi-Fi, Bluetooth, low power, wide area networks, that is called as LPWAN. Okay, and all these things, what is being done is it is connecting through a gateway or a router, or can connect directly to the internet. Then choosing which connectivity is best, it comes from the application. Okay, so which based on the application, we can choose the connectivity. But what happens is they all accomplish the same task, that is getting data to the cloud. That is all, whatever data is being sent, it is being moved to the cloud or stored in the cloud. So that is the work of this connectivity part. So this is done during using variety of methods which include cellular, satellite, Wi-Fi, Bluetooth, LPWAN, etc. So what they're going to do is they're going to accomplish the same task, that is getting the data to the cloud. Okay, then comes data processing and analytics. After the data is successfully uploaded to the cloud, okay, you have something called as computing software. Okay, the computing software and big data analytic process. This is done for the end user. For example, night vision and motion sensors are available. Okay, what they can do is they can detect the unauthorized activity. Okay, within an area, or within a, we can say it as a defined parameter. Okay, and then even though they are being sensed, okay, they can the signals can be sent to the user through an alert video or some other footage. Okay, so this is how signals can be sent. So this is where data processing analytics plays a major role. Then comes user interface and applications. What this IoT does is it leverages a user interface to make the data and information always ready and for practical consumption for the user. Okay, and this could be done by displaying the information on a dashboard or alerting the user through any set of notification. Okay, such as real-time system monitoring. Okay, like these, they can be alerted to the user. And this IoT, what it does is it enables provisions for live system monitoring also. This can be done using a mobile phone or a web browser app. Okay, these are the fundamental components of an IoT.